Hey everybody, we're starting on a new unit today. It's called Waves. We're going to talk about all different types of waves. We're going to talk about how they all transfer energy. We're going to talk about their properties, how they act. We're going to talk about sound waves. We're going to talk about the difference in speed and the speed of light and sound waves. We're going to talk about the electromagnetic spectrum and the Doppler effect. So down at the bottom, you'll see a couple things that we're going to use for grades. Okay, so the first thing I want you to do is I want you to watch the video that I have put on Google Classroom that's in addition to this, and it's going to talk about the wave part. So pause this and go watch that video. All right, once you're back, click on your packet so that you can complete this along with me. Remember, you can either print it out or edit it on DocHub. Okay, so the first thing we're going to do, and mine already have the answers, we're going to talk through it and you can pause yours and put the answers on it. All right, so the first thing is we're going to talk about the different points of a wave. All right, so the highest point in the wave is the crest. That's the top part of the wave. And if you notice, it's the part right here. And then we have the trough at the bottom. The amplitude is how much energy a wave carries, so it's right here. So the taller it is, the more energy it carries. And the wavelength is the distance between two waves. Now, frequency would be how many waves pass a point in a given amount of time. So if we had lines that were way closer together, there'd be a lot more crossing the same point in the same amount of time. All right, so if we look at this picture, we have the crest, trough, amplitude, and wavelength. So right here we've got 5 pictures, okay? And it says we want to know waves P and Q. Okay, it looks like they have the same wavelength. The length of the waves are the same distance apart. But P has twice the amplitude. It is twice as tall. It carries twice as much energy. All right, Q and R, okay, this wavelength is way longer, has twice the wavelength, but the amplitude is the same. All right, wave T shows steady frequency but changing amplitude. You can see the amplitude is going up and down. Amplitude is how high it is from the center. Wave S, so steady amplitude but changing frequency. Sometimes the waves are close together, sometimes they're far apart. And then Q and R. Q and R have low amplitude and a steady frequency. Have low amplitude, meaning they're very short waves, but they have a steady frequency. They don't change. All right, so let's look at this. These are called transverse waves, waves that go up and down like a water wave. Okay, but we also have waves that are called longitudinal waves. Longitudinal waves are like waves on a slinky. This is how sound travels. Okay, so in longitudinal waves, you still have a wavelength, which is the length between 2 points in the wave, but you have what's called compressions and rarefactions. Rarefactions are when they are spread apart, and compressions are when they are close together. Okay, now flip over to page 2. All right, at the top we see that waves are repeating disturbances that transfer energy. All waves transfer energy. It may be sound, maybe light, maybe actual matter, but they all transfer energy through matter or space. Okay, waves that need a medium, that is something like solid, liquid, or gas, are called mechanical waves. So sound waves are like this. They need something to travel through. Sound waves can't travel through space. Okay, and they obey what's called law of reflection, which says that the angle of incidence is equal to the angle of reflection. What that means is the angle that the sound wave or the light wave hits a surface is going to be equal to the wave that comes up. They will not change their angles. All right, the highest point in a transverse wave, remember transverse goes up and down, is called a crest. The less dense region of a compression wave, that's where it's spread apart, is called a rarefaction. And the number of wavelengths that pass a fixed point each second is called the frequency. All right, now you are going to turn to page 3. But we aren't going to do that just yet. I'll move these answers back there in just a minute. Turn to page 4. Okay, on page 4 we are labeling the parts of a wave. Okay, and you know at the top is the crest, at the bottom is the trough. The wavelength is the distance between two waves. The amplitude is how high it is. And this is the energy. So even though the wave is going up and down, the energy is going from left to right. That's why if you have something in the water, even though the wave is pushing it up and down, it still goes forward or backwards. All right, which of the above waves has the highest frequency? That means the most waves passing a point. I'm going to say C, they're the closest together, okay? The shortest wavelength means the closest together. That's also going to be C. Those are the two waves that are the closest together. The largest amplitude, that's going to be the tallest. That would be A. And the longest wavelength, that's going to be B, the greatest distance between them. And the smallest amplitude, the shortest one, is going to be D. So what I want you to do now is I want you to go back to page 3. I'm going to flip this back over so you can see it. And I want you to answer the questions on page 3. Okay, now some of them may be a little tricky, but I want you to look at the definition of the things we have just talked about, and I want you to answer these questions. Okay, so I'm going to zoom out just a little bit so you can pause this at the very end and look at it. Okay, and that is going to be it for today. So go ahead and pause this. Make sure you've got pages 1 through 4 complete.